Hello everyone and welcome to another video, and this is the 13th part for our playlist in which we are including the important questions which are helpful for job interviews and exam questions, and they are also helpful for the site engineers. So this is the part 13. Previously we have uploaded 12 parts. Let's start the part 13, and first point for part 13 is related to the quantity of cubes. Like on site, the quantity of cubes depends upon the quantity of concrete you are pouring, right? If you are pouring concrete from 1 to 5 meter cubes, then you need to just make one cube is required. If the range of the concrete which you are pouring on site is 1 to 5 meter cubes, then the required number of cubes is 1. And then if the concrete quantity is in between 6 to 15 meter cubes, then you need to make 2 cubes, right? Cubes, as you can see in the picture, these are the cubes. If the concrete quantity is between 16 to 30 meter cubes, then the number of cubes required are 3. If the concrete quantity is in between 30 to 50 meter cubes, then the number of cubes required are 4. If the concrete quantity is above 50 meter cube, then you need to add 1. 4 will be there, 4 cubes will be there, but you need to add 1 number of additional cube of each 50 meter cube. For every 50 meter cube addition, you need to add 1 cube extra. So you need to remember this. You can be asked by any interviewer in any interview for any sort of job for civil engineer, and if you are a site engineer, you must know these points. So this point was related to the cube quantities with respect to the quantity of concrete. And the second slide contains 4 important points. The first point is that the minimum height of a window recommended is 2.1 meters. This should be the minimum height of a window, like from here to here, right? This should be 2.1 meters. And the minimum thickness of lintel, first we should know that what is lintel. You can see this over this window or door. We placed a RCC member. And what is the function of this member? We place this lintel for the block masonry or brick masonry above the any sort of opening. It may be over the window, it may be over the doors or over ventilators. So if there is any sort of opening in your building, we need to place lintel over that opening, because this lintel supports the brick masonry or block masonry above it, right? So you can see the example of lintel in this image too. So what should be the minimum thickness of lintel? The minimum thickness of a lintel should be 15 centimeters. This is the thickness of the lintel. This should be minimum 15 centimeters. And the next point is related to cement bag. As we know that one cement bag, if you convert it to feet cube, it will be 1.25 feet cubes, right? This is the volume of the cement bag, and in meter cubes it is 0.0347. You need to remember these 2 points, because cement is the basic ingredient or basic material which we use on any sort of construction project. So you must know the volume of one cement bag. Volume of one cement bag In terms of feet cube, it will be 1.25. In terms of meter cube, it will be 0.0347, right? And in next point, number of cement bags in 1 meter cube is equal to 28.8 bags. If you know these both values, you can easily find this quantity. Let's check it out. As in this point, we know that we have 1 meter cube of concrete, right? This is concrete and its quantity is 1 meter cube. And sorry, number of cement bag in 1 meter cube, 1 meter cube, we have concrete, and we need to find the number of bags. But in this point, there is some point lacking. One important point is lacking. We don't know about the ratio of the concrete. It is 1 meter cube concrete, but we don't know the ratio. I guess number of cement bags in 1 meter cube. Oh, got it. They are not talking about the concrete. They are just saying that we have 1 meter cube cement. So in this 1 meter cube of cement, how many cement bags will be there? How many bags will be there? So as we know that 1 bag is equal to 0.0347 meter cube, right? And what is 1 meter cube? 1 meter cube will be equal to 1 divided by 0.0347. This will give you the answer if you calculate it. Let's check it out by using calculator. 1 divided by 0.0347. 1 divided by 0.0347 and is equal to, what the heck, man? Yeah, this is the answer, 28.8. So the answer is 28.8. So every time when you are asked to give your point in numbers or your answer in numbers, you need to round it up or round it down. So you can't write it in points, right? So we need to write it like 29 bags, or even you can write it 28 bags. Both are correct. So if you have 1 meter cube of cement, then in 1 meter cube of cement we will have 28 to 29 cement bags. So this was the point. Next point is related to responsibilities of a civil site engineer. What are the responsibilities of site engineer on any construction site? So this is one of the most asked questions. If you are applying for a site engineer position, then obviously the interviewer or the owner of the company will ask you this question. He will ask you, what do you think? What are the responsibilities of a civil engineer who is looking after a construction site? So I have mentioned few of the important responsibilities. So the following are some important duties and responsibilities of a civil site engineer on construction site. The first is that interpretation of drawing. You must know how to read drawings, how to interpret the drawings. And then second important point is you must know how to prepare bar bending schedule, and then allotting works to the labor and supervision of construction work or construction site, preparing schedule of material used and available, and then plotting line means leveling on construction site, or you must have the knowledge of surveying, and then preparing work chart schedules. Work chart schedules, it may include your weekly reports, right, or monthly reports. Got it. And the next point is checking the steelwork, slab, beam and columns before concreting. Any sort of steel work is done on construction site, you must need to tally these steel work with the drawings, structural drawings, and you need to check either the steel fixers have done the job correctly or not. You need to check the steel work after every activity before pouring of the concrete. And the next is supervision of curing process, keeping note of each and every casting work. You need to keep the record, right? Keeping record is another important point, and there are a lot of other responsibilities too, but these are the important ones. So you need to remember at least 4 to 5 points out of these points. Got it? And the next point you can have during any interview is that they can ask you, what do you mean by BOQ, right? For a civil engineer, it is very important point. You need to remember this. What is a BOQ? Basically, BOQ stands for bill of quantities, right? But what is bill of quantities? Bill of quantities is a document prepared by a cost estimator or quantity surveyor, we call him too, by a cost estimator to calculate the exact cost of project work by multiplying item work by their rates. It is the most important document for tendering and contracting. Bill of BOQ gives an idea about the cost of a project that is tendering firm willing to offer. So this is the basic definition, and from this image you can understand that in BOQ, this is an example format of BOQ. In BOQ, what we usually mention, we will have in first column we will have serial number, and then we have description of the item, whatever the item is there, and then we need to mention the unit of that item, and then the total quantity of that item and what is the unit rate, and then we will multiply this quantity with unit rate and we will get total amount. So these all total amounts of all the items will be add up at the end, and you will get the total amount of that project. So actually BOQ gives you an sort of abstract or general quantities and prices and amount of a project, and it is not a detailed estimation. After detailed estimation, you need to just describe item wise descriptions and their units, quantities, unit rates, and then total amount. Got it? This is what BOQ is, and this same thing is written here in the form of words, so you can convert it and you can write it in your own words too. So after BOQ, next point is, this is also an important question, and you must know that the what are the important and most commonly used or top civil engineering softwares. I hope most of you are familiar with the AutoCAD, right? SAP is there, StatPro is there, E-Tapes, Primavera P6 or Primavera Revit, ArcGIS for surveying, 3D SMAX modeling for modeling, and MX Roads for road design and analysis, Google SketchUp, StormCAD, it is used for storm saver design, and then WaterCAD, it is a software extensively utilized for hydraulic and water quality modeling applications, and then Microsoft Project, MS Project, Microsoft Project and Primavera both are used for project management, planning and scheduling. Easy Pro Builders Estimator, and then Stake, Takeoff and estimating softwares. These are softwares related to estimation. So there are around how many? 1, 2, 3, 4, 5, 6, 7. and then 14, 15, 16. I have mentioned 16 softwares. At least you must know 7 to 8 softwares, important softwares. You can get this question anywhere you go. And the next slide describes the few important terminologies you will face as a civil engineer, right? What is queuing? I have attached images too to make it easier for you. Queuing is the it protects the freshly concreted surface from water evaporation. Like when you do the fresh concrete, it is important that we need to stop the water from the concrete to evaporate, because hydration can badly affect the concrete. So we need to keep the water which is inside the concrete don't evaporate, don't come out of the concrete. So in this image you can see that this is one type of concreting. We call it ponding. He made different ponds and then he placed water in each pond. So this is what we call queuing. And then scaffolding. Scaffolding is the supporting system for the formwork. Whenever you do formwork for any sort of what we say, like if you are doing the formwork for column, any component, any sort of component, beam, slab, obviously to support those formwork you may need scaffolding pipes. So scaffolding is the supporting system for the formwork. And then ponding is the same thing which we have described in queuing. Ponding is actually a type of queuing, right? There are many methods for queuing the concrete. One of that is ponding. What is the purpose of ponding? We do ponding to keep water over a fresh floor of concrete. And the next is splicing. Splicing, we also call it, you may heard this word, dowel bars, right? Giving lap to steel for further heights. Like in this image you can see that if you have we are going to construct 2 or 3 floors, then after constructing the ground floor, obviously for first floor columns we need to keep the splices, we need to keep the dowels for further height of the building. So you can call it splicing or dowel bars too. Casting of concrete is actually concreting process of concrete is called casting too, right? This is, you can call this concreting or you can also call it casting. And the next term is admixtures. As we know that concrete is combination of 3 important ingredients, right? Cement, aggregates, and then water. But if you add 4th item into it, either to accelerate or reduce the water content or for the workability of concrete, then this 4th ingredient or ingredient will called as admixture, right? This is the admixture. So the it's sort of chemical. It has a lot of functions and advantages. I think we have discussed about the admixtures in the previous video, in the 12th video. If you want to know about admixtures in detail, go and watch that video. So chemicals used for accelerating or reducing water content for workability of concrete are known as admixtures. And the next term is masonry. Obviously, I hope all of you know what actually is masonry. Masonry is the constructing activity of brick blocks or stone wall is known as masonry. And next slide has few more terms. Mortar. What is mortar? Mortar is the combination of cement plus sand. Sand is actually the fine aggregate, right? So when you combine cement and fine aggregate, the product you will get is known as mortar. Like you can see in this image, for binding the bricks together we use mortar. Obviously we use its ratio most of the time 1:4, and the sealant is the next term. Sealant is a flexible rubbery type of material that is used to seal gaps in a joint. Like you can see in this image, this is a flexible rubbery type of material which we use to fill out the gaps in joints, right? If there are any sort of gaps or any sort of intersection or joints, if you want to fill out those gaps, we will use sealant. And then drywall. This picture is the example of drywall. A panel made from gypsum plaster that is wrapped in cardboard. It is commonly used as a fundamental material for framing a building, right? This is not actually a wall constructed using bricks, blocks or concrete. It is a drywall. It is actually a panel made from gypsum plaster that is wrapped in a cardboard, and it is commonly used as a fundamental material for framing of a building. Skirting is the next term. This image shows you the skirting, right? This is our floor, this is our wall. Material that covers up the joint between the floor and the wall in the interior of a building for aesthetic purpose. Wherever your floor, the point where your floor and wall joints, we usually use a material to cover this space. What is the reason of using covering this space? The only reason is that to get an aesthetic view, okay, to make it look beautiful and attractive. And the next point is, if someone asks you what is monocrete construction, a construction method that uses precast concrete panels which are bolted together to make concrete structures, right? These are actually different construction components are built away from the side, and then they are joined together with bolts, and then after that they are being placed to construct the structure. Got it? Like if you are constructing a building, these two are column, and there is no need to do the form working and then place the steel and then do the pouring of concrete. You can get a ready-made or precast beam and directly take it and place it here, and then use the bolts to put it together with the structure. That is called monocrete construction. So next and last point is, how can you find out the weight of a bar, steel bar, reinforcement bar? So unit weight, right? Unit weight of a steel bar, you can find it by using two formulas. It depends upon the unit. If you are asked to find out the weight in kg per meter, or either you are asked to find out the weight in kg per feet. If you are asked to find out the weight in kg per meter, then you will use d, this is not, square is not here, d square multiplied by L divided by 162. Then after that you will get the answer in kg, because here you have already multiplied it with the length. Then you will get the answer in kg. Got it? If the length of the steel is in feet, then you need to use this formula, d multiplied by length of bar divided by 533. You will also get the answer in kg, but the length here is in feet, and in this formula the length will be in meters, right? So this is the difference. If the length is in meters, you will use this formula. If the length is in feet, then you will use this formula. What is d here? D is the dia of bar in millimeters. You need to put the dia of bar in millimeter in both cases. In both formulas you will put the value of diameter of the bar in millimeters. This is the important point you need to know. So that's it for today. Thank you for watching. See you guys in the next video with more important points. So stay tuned and subscribe to the channel for more updates. See you guys in the next video. Till then, goodbye.